E1 Chapter 2 Regulation of Body Temperature. In this video clip, we will continue to learn first the mechanisms of thermoregulation, including shivering, action of the hormone thyroxine, and behavioral changes. Second, the process of thermoregulation. Third, heat stroke and hypothermia. Let's start with shivering. What is shivering? It refers to involuntary, rapid, repeated contraction of our skeletal muscles. In very cold condition, we will undergo shivering, involuntarily. Now, during shivering, the rate of respiration in muscle cells, of course, will increase, release more energy for muscle contraction. At the same time, the respiration rate increase will generate more heat to keep your body warmer. So under cold condition, your body will shiver involuntarily. And then we have the hormonal control. The hormone involved is called thyroxine. Thyroxine, it is secreted by the thyroid gland found in front of the trachea below the larynx. It helps to regulate the body temperature. In what ways? Let's learn. In cold condition, hypothalamus will detect the blood temperature decrease, and it will stimulate the pituitary gland to release a hormone, and the hormone will stimulate the thyroid gland to release more thyroxine, and more thyroxine will need to increase in metabolic rate of body cells. So as a result, more heat is generated to keep the body warm in cold environment. But remember, it is just a long-term response. If the question concerns immediate response of the body, you do not need to include the action of thyroxine. Please remember this. And then the behavioral changes under different conditions, in cold conditions and in hot conditions. Actually, they are common sense, but you need to relate the common behavior, how it is related to heat gain or heat loss. For example, in cold condition, of course, we will wear more clothes. Then, heat loss by convection can be reduced by the thicker clothes. Eating more warm food or hot food, so heat gain by conduction will be increased in this way. Still, under cold condition, we can hold a hand warmer. Then we can increase heat gain by conduction. And also curling up to a smaller surface area. This can reduce heat loss by convection. In the opposite condition, hot condition, wear fewer clothes, of course. So you need to explain. Heat loss by convection and evaporation will be increased in this way. And take in more cold food, for example, ice cream, iced drink, then heat loss by conduction can be increased. Fanning the body, then the heat loss by convection and evaporation of sweat can be increased. Of course, staying in shady places, this can reduce heat gain by direct radiation from the sun. Now let's go to the thermoregulatory process. Now, the thermoregulatory center is found in the hypothalamus of the brain. If you can remember, actually, we just finished learning about osmoregulation. Similarly, the osmoregulatory center is also found in the hypothalamus. So hypothalamus is a very important regulation center. Now, the hypothalamus itself, it has its own thermoreceptors, which can detect the blood temperature. And this temperature, you can call it internal temperature. it is more close to our real body temperature. But what about the skin? Okay, the skin, of course, can detect external temperature. So we have another group of thermoreceptors found in the skin. They work together. When they are stimulated, they can send the nerve signal to the hypothalamus. Okay, we will learn how these two groups of thermoreceptors work together in a moment. The thermoregulatory center in the hypothalamus actually contains two centers. The first one, heat loss center. Second, the heat gain center. As the name indicates, you know that they carry out opposite responses, actions. Okay, one can increase heat loss and the other one increase heat gain. And of course, the overall thermoregulatory process is working under the negative feedback mechanism again. Now, let's look at the thermoregulatory process now. Remember, we have mentioned about two groups of thermoreceptors. One found in the skin and the other group in the hypothalamus. Now, in a hot condition, the skin temperature and also the blood temperature tend to increase. This increase will be detected by thermoreceptors in the skin and also the thermoreceptor in the hypothalamus. And then they will stimulate the heat loss center in the hypothalamus, which will initiate or start different mechanisms leading to increase in heat loss and at the same time decrease in heat gain. With this mechanism, the body temperature can decrease back to normal. So of course, this is a negative feedback mechanism. Now, what are those mechanisms? You need to remember them, okay? Let's talk about them now. Those mechanisms can promote heat loss, include the first three that occurs all in the skin. Relaxation of erector muscle. Remember, when the erector muscle relax, the hairs on the skin can lie flat, okay, trapping only a thinner layer. So the insulation will be reduced, increasing heat loss. And of course, increasing sweating can increase heat loss by evaporation. And vasodilation, remember, it occurs in the skin arterioles, which increase the blood flow near the skin surface, okay, to increase heat loss by radiation, conduction, and convection. So the first three concerns the skin. They are responsible for promoting the heat loss. What about decreasing heat gain? Okay, decreasing heat gain goes to the last mechanism. Okay, decrease the secretion of thyroxine. But remember, it is a long-term response only. What about structural response? Now, the subcutaneous fat layer will get thinner. Again, it is long-term response only. And then behavioral, we wear fewer clothes and take in more cold food. Okay. Now, these are the mechanisms to promote heat loss and decrease heat gain. Now, let's go to the opposite condition. If we are in a very cold environment, so the skin temperature and also the blood temperature tend to increase. Now, the decrease in skin temperature will be detected by thermoreceptor in the skin, and the decrease in blood temperature will be detected by the thermoreceptors in the hypothalamus. Okay, both groups of thermoreceptor will feed the information to the heat gain center inside the hypothalamus, and it will initiate start mechanisms leading to decrease in heat loss, increase in heat gain, so that the body temperature can increase back to normal. Another negative feedback mechanism. So what are those mechanisms? Okay, they include the physiological. Okay, again, we focus the important three. The first three, reducing heat loss, occurs in the skin, so the skin response is always important. A contraction of the erector muscle so that the hairs stand upright, trapping a thicker layer of air near the skin surface, acting as a good insulation. So reducing heat loss, reduce the sweating. Okay, so heat loss through evaporation will be reduced. And vasoconstriction of the skin arterioles, so less blood flow through the skin surface to reduce heat loss through conduction, radiation, and convection. And then the last two involve increase in heat gain. Okay, the first one is an immediate response. Okay, shivering, involuntary, repeated, rapid contraction of our skeletal muscles, increasing respiration rate, increase heat generation. And the second one will be increase the secretion of thyroxine, okay, increasing the metabolic rate of body cells. But again, remember, it is only a long-term response, okay, not immediate response. Structural, also long-term, the subcutaneous fat will grow thicker, okay, better insulating layer. And then behavioral, wear more clothes, take in more warm food under cold condition. Okay, so we finished talking about the thermoregulatory process in a healthy person. But what about if our body fail to regulate our body temperature? Then we have some health problems related to thermoregulation. They are quite opposite. The first one is heat stroke, 中暑, and then hypothermia, okay, 體溫過低. They are in opposite condition, but both of them are quite dangerous. Okay, first, heat stroke. In what condition? What is the immediate cause? Of course, you can think of a very hot environment, humid, no wind. Okay, but please remember why the body temperature will increase, because the rate of heat gain is greater than that of heat loss. Then your body temperature will increase slowly, gradually, but up to a dangerous level. For example, higher or equals to 41 degrees Celsius, it will become very dangerous, okay? And in the opposite condition, in very cold environment, the rate of heat gain is smaller than that of heat loss. Then your body temperature will gradually drop until the dangerous level, okay, equals or less than 35 degrees Celsius. Then what about the symptoms, the problems? In heat stroke, okay, the skin may get hot, red, and fever may develop. And finally, the person may become unconscious, okay, losing conscious. Fatal, that means it will lead to death if not treated properly. Okay, this is heat stroke. For hypothermia, the person will feel sleepy and confused, so affecting your mental function, and may have irregular heartbeat. So finally, it may lead to heart failure or even death if not treated properly. Okay, so try to have some idea about these two problems related to thermoregulation. Now, let me mention about heat stroke. Do not mix up heat stroke with the only word stroke, okay? If you talk about stroke, it refers to in Chinese, okay, stroke means 爆血管, okay? It is completely different from heat stroke, so please do not mix them up. Okay, so how to avoid these problems? Okay, to avoid heat stroke, you should maintain good ventilation for indoor activities. Avoid doing vigorous exercise under a very hot environment. Okay. Now you need to be well hydrated. Okay, drink more water. Now, why dehydration will easily lead to heat stroke? Because if your body is lacking water, you cannot produce enough sweat for sweating to increase heat loss by evaporation. Okay, so it's about sweating. Cannot be done properly. Okay, so you need to drink enough water in hot environment to enable or to allow the sweating to be carried out efficiently. Okay, another behavior will be wearing light clothes, okay, reducing the heat absorption by radiation. And stop exercising, okay, outdoor. You should take rest in shady places. What about hypothermia? Just common sense. Wear more clothes, okay. Take in warm and hot food, okay, drinks, so that you can increase heat by conduction, okay, and keep the environment, the home environment warm. This can prevent hypothermia. Okay, to recap, in this video clip, we have learned some mechanisms of thermoregulation, including shivering, action of thyroxine, and behavioral changes, and then the process of thermoregulation. Finally, when your body fails to regulate body temperature, the problem include heat stroke and hypothermia. Sorry, these two words should stick together to become one word, heat stroke, instead of two words.